if those are anyone who is interested in results or questions that Ramanujan asked that are easy to understand, I highly recommend going to the problems he submitted to the Journal of the Indian Mathematical Society. So he began submitting these problems in 1911, before he went to England. So there are 58 of these problems, and along with two of my former students, Suni Kang and Yunsa Che, we wrote an article about all of them. So indicating the work that had been done on them, and since Ramanujan posed the problems. So a number of them are very easy to understand. For example, I think one is n factorial plus 1 is a perfect square for n equals 457. So are there any other values for which n factorial plus 1 is a perfect square? We don't know. So it's an unsolved problem. There are a couple problems that are unsolved having to do with approximations. And a number of people have worked on these problems. They actually involve the exponential function. So these two problems are in Ramanujan's notebooks as well as in the Journal of the Indian Mathematical Society. I should say that Ramanujan was very, very good at finding approximations, and both numerically and in terms of functions. In fact, many times I've been absolutely astounded how he could make such approximations, without any use of computer algebra, for example. He didn't have Mathematica, and he had many asymptotic expansions. So he would never use the word asymptotic. He would just write out, say, the first few terms, and then say nearly or very nearly after them. Oh, yes. So the famous taxicab number 1729 with its two representations are part of a problem that Ramanujan submitted to the Journal of the Indian Mathematical Society. So in particular, he asked for solutions of Euler's equation, x cubed plus y cubed plus z cubed equals 1. So, and then he gave a family of solutions. And he then listed 7 of them. I think there's 6 or 7. And one of them was the famous 1729 representations.
I see. But speaking about this list of 58 problems, that some of these were just open problems, right? They were not actual results.
So most of them had solutions. There are a number of them had to do with series identities and evaluations, and were more or less in the spirit of mathematics that was being done in India at that time. Mm-hmm. But a number of others were far away from anything being done in India at that time. And some of these, as I indicated, are open problems. And in terms of elementary problems, there are some beautiful algebraic identities that he submitted as problems. And a couple of them are, I found just astounding because, no one would ever think of these identities. And, after we see them, we can prove them. But, I don't know how he ever found these